Hello everybody, today we are going to discuss how can we find the first derivative of the product of two functions u and v. If you have product of two functions u and v and you wanted to find its derivative, so you have to use the product rule, which is u prime v plus u v prime. So you have to find derivative of the first times the second plus first times derivative of the second. For example, if you have f of x equals to x squared minus 1 times 3x plus 4, and you wanted to find f prime, or the first derivative, so you have to use this rule. F prime equals first times derivative of the second plus second times derivative of the first. Apply this rule. First, which is 2x squared minus 1 here, times the derivative of the second, derivative d dx of the second, which is 3x plus 4, plus second 3x plus 4 times the derivative of the first, d dx of 2x squared minus 1. So we have 2x squared minus 1, derivative of 3x plus 4, derivative of the second, which is 3, because derivative of 3x is 3 and derivative of 4 is 0 because 4 is a constant, plus 3x plus 4 times the derivative of the second, 2x squared minus 1. Derivative of 2x squared is 4x because you have to put the power down, and we have 2, so 2 times 2 equals 4. Subtract 1 from the power, so we have 4x. Derivative of 1 equals 0. This is f prime, or the first derivative. If you want to simplify this expression, you may expand the brackets and simplify. Example number 2. F of x equals x power 3 times root x minus 1. Find the f prime. So to find f prime here, you have to use the product rule. First, which is x power 3, times the derivative of the second, and you have to consider root x as x power half. Derivative of the second, the derivative of root x, or x power half, minus 1, plus second x power half, which is root x, minus 1 times the derivative of the first. Now you have x power 3 derivative of this bracket equals, put the power down, so you have half x, subtract 1 from the power, half minus 1, which is negative half, derivative, the constant is 0, plus first times the derivative of x power 3, this is the second, times the derivative of the first, x power 3. So we have x power half minus 1 times the derivative of x power 3, put the power down, 3, and subtract 1 from the power, so you have x power 2. You can expand the brackets if you want to simplify, or you can leave this expression as a final answer for f prime of x. Example number 3. Here you have f of x equal the product of these two functions. So f prime is derivative of the first, bracket, here x power 3, put the power down and subtract 1 from the power, so you have 3x squared. Derivative of 2x, 2, derivative of the constant 5, 0. So derivative of the first times the second, you have to copy paste the second, plus first, just write it, times the derivative of the second, put the power down, so 7 by 3 is 21, subtract 1 from the power, and 8x squared, put the power down, so you have 16x, because you have to subtract 1 from the power, so x power 2, it will be x to the power 1. Derivative of the constant 1 is 0. You can multiply, or you can expand the brackets to find a simple form, or you can leave the brackets as it is, and this is your final answer for f prime of x. Here we have f of x, or y, equals e power x sine x, then find y prime. We have here product of two functions, so you have to apply the product rule. Derivative of the first, derivative e power x is e power x times second plus first times the derivative of the second. The derivative sign is cosine. So this is the quotient rule. If you have a quotient u over v and we wanted to find its derivative, so you have to use this rule. V squared, and above you have u prime v minus uv prime. For example, if you have this quotient 3x plus 5 over x squared minus 2, to find its derivative, the denominator squared down, and above you have derivative of the first, the derivative 3x plus 5, which is 3 times second minus, according to the rule, it is minus derivative of the second, derivative of the denominator, which is 2x times first times the denominator, over the denominator squared. Now you can expand the bracket to simplify to get this final answer. Now we have the chain rule. If you wanted to find the derivative of f of x, which is 7 to the power x squared plus 2x, derivative of f of x here, according to the rule, we know that, as you can see the rules in these orange boxes down, y equals a power x, so its derivative is a power x ln a number to the power x, so its derivative is a number a to the power x, so its derivative is a power x ln a. And a power u, a power function, equals a power u ln a times u. So you can apply this rule. 7 to the power x squared plus 2x, its derivative is 7 to the power x squared plus 2x times derivative of the power, derivative x squared is 2x, derivative of 2x is 2 times ln 7 according to this rule. Another example for the chain rule. If y equals e to the power 2x plus e to the power sec x, we wanted to find y prime. We want to find the first derivative. To find the first derivative here, e to the power 2x, its derivative is e power 2x is e to the power 2x times the derivative of the power, which is 2, plus e power sec x is e to the power sec x, its derivative is e to the power sec x times the derivative of the power, and the derivative of the power, derivative of sec, is sec x tan x. Another example, if y equals the sine e to the power 2x, then find the first derivative y prime. I know that derivative of sine is cosine, but you have to consider the chain rule because it is not sine x, it is sine e to the power 2x. So y prime here equals derivative of sine e power 2x is cosine e power 2x according to the table of derivative, times derivative of what inside, derivative e to the power 2x is e to the power 2x times the derivative of the power, which is 2. So y prime can be modified to be 2 e power 2x cosine e power 2x. Another example, if y equals ln x squared plus 1 plus x e to the power x to the power 2 plus 2. To find the derivative of this y, derivative of ln x squared plus 1, according to this rule down in the box, the last box here, y equals, if y equals ln u, so its derivative is u prime over u. So here, ln x squared plus 1, ln u, this is u. So apply the rule, u prime over u, x squared plus 1, the bracket here. u prime over u prime is the derivative of x squared plus 1. Its derivative x squared, put the power down and subtract 1 from the power, so you have the derivative 2x. Derivative of the constant 1 equals 0. Plus, here we have a product rule. product of two functions, x and e power x squared. So you have to apply the product rule. Derivative of the first, 1 times the second e power x squared, plus first x times the derivative of the second, which is e to the power x squared, times derivative of the power, which is 2x. And here derivative, the constant, equals 0. Another example, if y equals sine 4x squared minus 2 e power 3x. So y prime equals derivative of sine is cosine. Sine 4x squared is cosine 4x squared. Times the derivative of what inside, according to the chain rule. Derivative 4x squared, put the power down here, 2 by 4 equals 8, and subtract 1 from the power, so we have x to the power 1, or simply x. Here, e to the power 3x is e to the power 3x times the derivative of the power, which is 3. So you have 3 by 2, which is 6. If y equals ln e to the power x to the power 6 minus sine 2x, find y prime. You have to remember this rule here. If ln a to the power n, ln a to the power n, you can put the power down, as you can see in the last line here. Put the power down, so you have n ln a. And you have to remember that ln e power x, put the power down, equals x ln e, and ln e equals 1, so you have the final answer is x. Now you can use the same rule. Put the power down, so you have x power 6 minus sine 2x ln e, and the ln e equals 1, so you have to find the derivative of this bracket, which is 6x power 5. Put the power down and subtract 1 from the power, so you have 6x to the power 5. Derivative sine is cosine, times the derivative of what inside, which is derivative 2x, which is 2. And this is our final example. If y equals sec 3x squared minus 1 minus 2 e power x, derivative of sec 3x squared minus 1 is sec 3x squared minus 1 tan 3x squared minus 1, because we know that derivative of sec x is sec x tan x. But don't forget to find the derivative of what inside. So derivative of sec is sec tan, times the derivative what inside, which is 3x to the power 2. Put the power down, so we have 2 by 3, which is 6x to the power 1, because we have to subtract 1 from the power. Derivative of 2 e power x, derivative e power x is e power x. You can simplify this expression if you want. And this is our final example here. Y equals ln cosine x minus 1 minus ln 2 to find the derivative. Here derivative ln bracket ln u is u prime over u. So cosine x minus 1 ln u is cosine x minus 1. So you have to set it down here and find its derivative up. Find its derivative above. Derivative of cosine x is sine x, and derivative of 1 is 0. This is a constant, so derivative of the constant equals 0. See you next time. Thank you.